Dear students, so we are starting our next topic in this introduction to energy sources and its conversion, that is nuclear power plant. In previous videos, we have seen two power plant. One is thermal power plant and second one is a hydroelectric power plant. Now in this video, we will see the nuclear power plant. So we'll see this nuclear power plant one by one. So in nuclear power plant, the nuclear energy is released from radioactive materials due to the fission reaction is utilized. In nuclear power plant, the nuclear energy which is released from radioactive material or radioactive substances due to nuclear fission reaction is utilized, and this is utilized to heat the water and convert this water into an superheated steam. So we convert this heat, we convert water into a superheated steam by using this heat. So the rest of electric generation process is similar to steam power plant or thermal power plant. So the main problem of this nuclear power plant is careful handling of radioactive fuel or radioactive substances which is used in nuclear reactor. So in nuclear power plant, we require a nuclear reactor. It is a main part of this nuclear power plant system. And other parts like steam turbine, condenser, feed pump, then we have cooling towers. So all other parts, they are same, or electricity generation process is same as that of the thermal or steam power plant. So here from nuclear energy, we convert this nuclear energy into heat energy, then heat energy into thermal energy. Then from thermal energy, we passes this high pressure, high temperature superheated steam to steam turbine. We convert that thermal energy into mechanical energy, and by using generator, we convert mechanical energy into electrical energy. So this is the energy conversion takes place in case of nuclear power plant. Now, the radiation which is from the nuclear fuel, they are very harmful and dangerous to human being. So therefore, the complete shielding is required of this nuclear reactor. So shielding is a very necessary part so that the harmful radioactive rays, it does not goes outside the nuclear reactor. So a nuclear reactor, radiation from nuclear fuel are very harmful. So after useful life of nuclear fuel, the disposal of this nuclear waste is also very important. This is the second problem that is faced in nuclear power plant. First power plant, we required a complete shielding of nuclear reactor because it harm as well as dangerous for human being. Similarly, the disposal of this waste material, nuclear waste material, it is also a very major problem. The installation cost of this nuclear power plant is very high, but the operational and production cost per unit electricity is very low or very economical. So will I have this diagram of this nuclear power plant or a layout of nuclear power plant. So if you see, only difference between thermal power plant and steam power plant is, so in steam power plant, in this whole system there is a boiler. Now boiler is replaced by this nuclear reactor and heat exchanger part. All other parts, that is turbine is there, generator is there, condenser is there, cooling tower is there, feed water pump is there. This all other parts is same as that of the thermal power plant. So only we require heat exchanger, which exchanges heat between water and this heating water. So we exchange heat and we convert that heat into a steam. So again, we get a superheated steam. That superheated steam is import on turbine and that will rotate the work. From this output of turbine is low pressure, low temperature steam. It is then passes through condenser where that low pressure, low temperature steam is converted into a condensate water. And this from condenser, this condensate water is transferred to feed water pump where the pressure of water gets increased. So this is all a working procedure or principle of working is same as that of nuclear power plant, that of thermal power plant. So we'll see the remaining part of this nuclear power plant, the mainly what is meant by nuclear fuel, nuclear reactor, moderator, controller, pressure vessel, all these parts of nuclear reactor, we will see a depth, but other parts is as like thermal power plant, that is steam turbine, generator, cooling tower, condenser, feed water pump. So these all other parts are same except the nuclear reactor. In nuclear reactor we have various parts and the heat exchanger. So we'll see these components of nuclear power plant one by one. So this is the another diagram of nuclear power plant. So if you see in nuclear reactor, we have this part is heat exchanger. This part is uh, nuclear reactor. This part is pressure vessel. Then in that there is control core of the nuclear reactor. Control rods are there. Moderators are there. So this part is pressure vessel. So inside pressure vessel we have all this nuclear core and moderator and control rods there. Outside we have nuclear reactor. Now here this part is heat exchanger. Other parts like this steam turbine is same. Then we have electric generator, then transmission line, then we have condenser, this cooling tower, this all other parts are same. Similarly, water pump, that is feed water pump. These all other parts are same as like thermal power plant. So this is the another diagram of nuclear power plant where the flow of water is supplied to this power plant is shown, and how as water is converted into steam, steam is again converted into low pressure steam and low temperature steam, that again converted into a water, and we get uh, the electricity every time, every cycle. So we will have the first component of this nuclear power plant. It is the fuel, nuclear fuel. So mainly these three fuels are used as nuclear fuel. That is uranium 92 to 35, plutonium 94 to 39, and uranium 92 to 33. So these are the three nuclear fuels that is mainly used in nuclear reactor to release the heat energy. Now this heat energy is released by nuclear fission reaction. So when uh, the nucleus fission reaction is nothing but the when nucleus is split up into two atoms, and after splitting we get large amount of energy that is released after nuclear fission, that is splitting of one atom into two atoms. Similarly again this atom will splitting into two parts. Similarly this atom is splitting into again two parts. So this chain reaction goes on there. So this is the main three fuel, nuclear fuel, that is used in nuclear reaction. Now, in uranium ore and the uranium 9233, it is available only up to 0.7%. All other remaining it is uranium 92 to 35. These are the all parts, that is uranium 92 and 32. So only uranium ore and 92 uranium 233 is available only up to 0.7. Other two fuels, that is mainly plutonium and uranium 233, they are formed in nuclear reactor during fission process of this uranium 92 233. Now there is another nuclear fuel, that is thorium 90 232. It is formed due to the absorption of neutron by this 92 uranium 233 without fission. Now for thorium, we does not require fission process, so it is absorbing the neutron. So these are the nuclear fuels. It is mainly used. Now in homogeneous reactors, the fuel and moderator. Now these two important things are there. One is fuel and another one is moderator. These two components are there in nuclear reactors. So in homogeneous reactor, this fuel, that is uranium, and moderator, mainly carbon is there, are mixed uniformly and used in the form of rods or plates in the nuclear reactors. So it is in case of homogeneous. In case of heterogeneous reactor, the fuel is used in the form of rod and moderator is surrounds them. This is in case of heterogeneous. In homogeneous, we have a mixture of both moderator as well as fuel. So we have a mixture of uranium and carbon, which in the form of rod or plate. So in heterogeneous, fuel is used in the form of rod and moderator is surrounding that. The fuel rod is a clad with aluminum, stainless steel, or zirconium to prevent the oxidation of fuel or to prevent the oxidation of nuclear fuel. So this is the first part of this nuclear reactor, that is the nuclear fuel. Now we have another part of this nuclear reactor, that is the moderator. So the moderator is a material which is used to reduce the kinetic energy of the fast neutron. This is the main function of the moderator, to reduce the kinetic energy of fast neutron. So we can reduce the kinetic energy from 13,200 kilometer per second to 2,200 meter per second, kilometer per second. So we have reduced this amount of kinetic energy of fast neutron within the fraction of second to maintain this fission chain reaction. So this is the function of moderator. Now there are different types of moderators that is used. So first one is H2, then we have D2, N2, C, and a carbon. Then we have heavy water and beryllium. These are the some important moderator are there. Hydrogen, then we have D2, then N2 is a nitrogen, carbon, and these are the some important moderator. Then we can use ordinary water, also a moderator, only with we have enriched uranium is there. So what is meant by enriched uranium? So enriched uranium is nothing but the enrichment is a process which increase the amount of uranium 92 to 35. Now whereas graphite, then heavy water and beryllium, it can be used with natural uranium. The major characteristics of these moderators are it is ability to slow down the neutrons, resistance to corrosion, then it has very high melting point, high chemical stability, and non-absorbent of the neutrons. So these are the characteristics required for the moderators. So this is the second part of nuclear reactor, that is the moderator. Now we have a next part of this component of this nuclear power plant or nuclear reactor. It is the control rods. Now control rod. So if you see in this, we have moderator and control rod are this. Now these are the control rods uh, which catches the neutrons, and these are the moderators, and these are the control rods. So the function of control rod is to start the nuclear chain reaction, then to maintain the chain reaction, and to shut down the chain reaction. So this is the main function. Now the function of control rod is to start the nuclear reaction. When we start the reactor from cold, we start the power plant, or we can say a reactor from cold, we have to start this nuclear chain reaction. Second, we have to maintain the chain reaction in steady state condition, that is in continuous condition or steady state condition. We have to maintain this chain reaction, nuclear fission chain reaction. And to shut down or to off this nuclear chain reaction automatically under some emergency condition. So if you have some emergency condition, we can shut down this nuclear reactor automatically. Now, uh, the material which is used for this control rod, it must have very high absorption capacity of neutrons. In moderator, there is no requirement of absorption. Here, there is very high absorption capacity. So the common used control rod materials are cadmium, boron, and hafnium. So these are the materials which is used as a control rods because it has very high absorption capacity of the neutrons. Now we have another part, that is the shielding. Now this shielding is very much important. So neutrons, then gamma rays, and all other radiation, they are efficiently absorbed by a concrete or steel. So the shielding is required of a nuclear core, or we can say a pressure vessel, by means of this concrete and steel, so as to this neutron, gamma rays, and all other radiations, they are do not travel to this nuclear reactor outside the nuclear reactor. So how this shielding it can be done? So the inner lining of this core is made up of 50 to 60 centimeter thick steel plate. So first we require 50 to 60 centimeter of steel plate. This is the inner lining of the core, and it is further thickened by few meters by using a concrete layers. So in this line there is a concrete layer, here there is a concrete layer. So this whole layer forms a shield. So we have an inner lining which is made up of 50 to 60 centimeter thick steel plate, and it is again thickened by a few meters of concrete. So the lining of steel plate, it absorbs these engines and becomes heated, but prevent adjacent wall. So prevent this concrete wall of reactor vessel from becoming heated. So this the thermal shield is cooled by circulating water. By using circulating water, we can cool the thermal shield or shield. So this is the fourth part of this nuclear power plant. or nuclear reactor. And the next part, it is the pressure vessel. Next part, or it is also called as a reactor vessel. So in this reactor vessel, it consists of reactor core, reflector, and shield. All these three parts are inside this reactor vessel. We have main core part, that is reactor core, then reflector and shield. This reactor vessel is also provides entrance and exit passage to direct the flow of coolant. So coolant can be flow inside this reactor vessel by using this entrance and exit passage. Now this reactor vessel, it should have very high withstanding capacity of pressure, that is more than 200 bars of pressure that can be withstand by using this reactor vessel or pressure vessel. Now at the top of vessel, the hole is provided to insert the control rod. I will again I will give the image again of that reactor vessel, so we can have the hole and all that, reactor core, reflector, shield, then we have control rods and all that. So the reactor core is generally placed at bottom of the vessels. The nuclear reactor, they are classified on the basis of neutron energy, fuel used, moderator used, and coolant used. So this reactor vessel, it may be classified into different types of classification based on its criteria, on the basis of neutron energy, on the basis of fuel used, on the basis of which moderator is used, on the basis of which coolant is used. So we'll see this classification. So on the basis of neutron energy, nuclear reactor, they are classified into fast reactor and thermal reactor, which is based on nuclear energy. Second, on the basis of fuel, they are classified into natural fuel reactor and enrichment uranium fuel reactor. It is based on which type of fuel is used. We use a natural fuel or enriched uranium fuel. Now, based on which type of moderator, they are classified into water moderator, heavy water moderator, graphite moderator, or beryllium moderator. Similarly, on the basis of coolant, this reactor is again classified into water-cooled reactor and gas-cooled reactor. So these are the main parts of this, we can say, nuclear power plant, that is the nuclear reactor. All other parts, they are same, and the electric generation process is also same as like the steam power plant. So this is the same part. So if you see this core, we can say this pressure vessel or reactor vessel, it consists of this reactor core, then we have a reflector and this control rods and shield also. So this part is a shielding part. And this reactor vessel, it is placed at bottom of this nuclear reactor. And this main core, or you can say reactor vessel, it should withstand the temperature of pressure of 200 bars or more than 200 bar pressure it can withstand. So this is about the nuclear reactor, which consists of the fuel, then moderator, then control rods, shielding. So this is the shielding and reactor vessel. So after we have other parts is same as that of steam power plant, that is we have steam turbine, electric generation, then transmission of this electricity into transmission lines. Then we have condenser where we can condensate this steam into water. Then we require a cooling tower where cooling water is circulating inside this condenser. Then we have feed water pump where water is pressurized and then it passes through the this heat exchanger. So all these remaining parts or remaining power generation process is same as that of steam power plant. Now we'll see the different advantages of this nuclear power plant and disadvantages of nuclear. So advantages of this nuclear power plant. There are lots of advantages as compared to other power plants. So first one is since the requirement of fuel is very small, so cost of fuel transportation and storage, it is very small. In case of thermal power plant, the cost related to transportation of coal and storage of coal is very high. But in case of this nuclear power plant, it is very low. Second, nuclear power plant needs less space as compared to any other power plant. It may be a hydropower plant, it may be a nuclear power plant of same capacity. Third one is nuclear power plant is economical or very economical to produce large electricity. So we can produce very large amount of electricity development by using this nuclear power plant. Next one is nuclear power plant can be located near to the load center. So we can avoid this transmission cost or transmission loss. Also, the fuel does not require uh, a coal or large amount of water. Small amount of water is required. The nuclear power plant is most economical to generate large capacity of power, say 100 megawatt and more than 100 MVA. It produces high amount of energy in every nuclear fission process. So from that, it is very economical to generate a large power. Next, using small amount of fuel, the plant produces large electrical energy. Next, this nuclear power plant very reliable in operation. Then the large number of nuclear fuel are available in the world. So nuclear power plant can generate the electricity for thousands of years continuously. And the nuclear power plant is very neat and clean source of energy compared to steam power plant. Not 100% clean, but it is neat and clean than your steam power plant. So there are number of advantages of this steam power plant. Now we have, sorry, advantages of this nuclear power plant. Now we have disadvantages of this nuclear power plant. So first disadvantage is the initial installation cost is very much higher than compared to other power plant or power station. It may be thermal or it may be hydraulic. Initial installation cost is very high. Second one, nuclear fuel. It is very much expensive and difficult to recover. It is exhaustible. It is non-renewable source of energy. Third one is the capital cost is higher in respect to of other power plant or power station. Now for this nuclear power plant, we require a good technical knowledge. Is required to operate this type of plant. So salary, other maintenance cost, bill, all that higher than other power plant. Next, there is a chance of spreading of this radioactive pollutions, because if there is some leakage of this radioactive fuel or radioactive energy or waste of this radioactive, it produces a hazardous effect to human being. Next, nuclear reactor does not respond efficiently when there is a fluctuating load. This is the main disadvantages. If there is a demand supply ratio is very high or low, so during this fluctuating load, the nuclear reactor does not respond efficiently. So it is not suited for varying load. So load should be constant in case of this nuclear power plant. And last, The cooling water requirement is very much higher than the coal-based power plant or gas plant. It is twice that of the steam power plant or thermal power plant. So this is all about the nuclear power plant. We have seen what is meant by nuclear energy, what are the different parts of nuclear reactor, and then advantages of this nuclear power plant, disadvantages of this nuclear power plant. So thank you very much for listening. Thank you.